Okay, so these are kind of long, so I might have to do two videos, but we'll see. Well, all right, so question two. You wish to test the following claim that uh, the claim on the alternate at a significance level of alpha equal zero point zero 0.01. And we have that the null hypothesis is that the two means are equal, and the alternate is that mean 1 is less than mean 2. So we believe both populations are normally distributed, but we don't know the standard deviations for either of them. However, we also have no reason to believe that the variances are not equal. So we're going to assume that they are. You obtain a sample size of N1 equal 18. And let me write some of this down. So when we go over to a word page, we've got it. So our first sample size is 18 with a mean of 62.6 and a standard deviation of 11.2. And that's our first population. And then the second one, we have a sample size of 10 and a mean of 75.2 and a standard deviation of 17.8. Okay, now we want to go through the steps of a hypothesis test here. Let's notice that it is a left-tailed test, or we can think of it as our rejection region will be on the left. We'll be able to just look up the critical value, or really look up the test statistic, um, and tell whether or not it lies in the critical region. Now, um, first though, we've got some calculations to do. Notice the sample size are both small. They're both less than 30. Now, if even one of them is less than 30, we have to use the calculations for small sample sizes. All right, so if either one of them is less than 30, we need them both to be 30 or more to be able to use large sample size formulas. Okay, now I pulled up just to help us the formulas. So let's notice for small sample hypothesis test, here is our T calculation right there. And in fact, I might try to copy that over to another page. Now, incidentally, the formula sheet we were just looking at is the formula sheet that is underneath the tables and formulas in Blackboard. So if you look under that designation, you'll find this formula sheet. Now, of course, these are also in the book notes. So if you look at the book, you'll see these formulas are in there as well. All right, so there's really two things we have here that we're going to have to do to get the critical value for these small samples. All right, so first, um, let's start with this pooled variance is what this is called, and we have to do this first. And I'm sorry, my dogs are making noise in the background. Come here, stop. All right, now, so I'm gonna do the pooled variance first. So I'm gonna do this calculation. Honey, mommy's working. Calm down. All right, puppy. All right, so this pooled variance. So first we need the first sample is 18 in it, minus 1. And then our standard deviation for the first sample was 11.2. We're going to square it though, so it's 11.2 squared. And then we want to take sample 2, which is, let's see, there's 10 in it. 10 minus 1. And then the second whoops, that was weird. I don't know what happened there. And then the second standard deviation was 17.8, and I'm going to square it. I know my 8 doesn't look quite right. And all of that goes over sample 1 size plus sample 2 size minus 2. So 18 plus 10 minus 2. All right, so we got to do these calculations first. So 18 minus 1 will be 17. And then I'm going to do 11.2 squared, which is 125.44. And then I will do 10 minus 1 is 9. And then 17.8 squared. That is 316.84. And all of that is over 18 plus 10 is 28 minus 2 is 26. All right, now let's finish up the top. That ends up being 4,984.04 over 26. And then I'll do that final division. And I get just 26. That seems odd. Let me put that in again. Yeah, I was right. That answer didn't seem right to me. And it was not. Just a mistake when I hit something on the calculator. So it was 191.69385. All right, now that I've got my pooled variance, I'm going to go back up to the formula that I had above and plug that in. And I might just sort of recopy that formula down below so we don't have to scroll up. All right, so now we need to fill into this to get our critical value. And there's that pooled variance right there that we calculated first. All right, so we want to take our first mean minus our second mean. All right, so let me turn this on. So we want T equals the first mean minus the second mean, which was 62.6 minus 75.2. All right, now we want to subtract the difference. Now, most of the time, the difference is going to be 0, but let's double check and go back here. Yes. All right, so if I were to take this, this mean right here to the other side, we'd have mean 1 minus mean 2 equal 0. So the difference is 0. So for them to be equal to one another, that means the difference between them is 0. Now, sometimes there'll be a hypothesis test where the difference is something other than 0. But the majority of the time, we're going to just have 0 for our difference. And we don't have to really subtract anything there. Let me find where I was. Okay. So really, the difference is 0. We don't have to write it there if we don't want to. All right, and then square root of that pooled variance, and I wrote that down, so it was 191.69385. And we're going to multiply that times 1 over the first sample size, which was 18, and 1 over the second sample size, which is 1 over 10. Okay, now let's do the top calculation. So 62.6 minus 75.2 ends up being negative 12.6 on top. And then on the bottom, I need to do this parenthesis first since it's in parentheses, and then we'll finish off that square root all at once. So I'm going to have 191 0.69385 times whatever 1 over 18 plus 1 over 10 ends up being, and it's 0.15556. All right, and then whoa, okay, and then let's go ahead and let me kind of scroll a little bit. There we go. All right, now I'm going to finish the entire denominator. So I'll still have negative 12.6 on top, but let me finish that denominator. Okay, so that ends up being 5.46076. And then when I divide these two out, it's negative 2.307307. 0737. All right, now we are now going to look this up in Excel using the t-distribution. Let's remember that this was a left-tailed test. It was a less than. So what we look up will be our p-value. But degrees of freedom for these types of two-sample tests, we subtract 2. So we do n1 plus n2 minus 2. Sorry about that. There seems to be a vicious response to the mailman. Okay, so let's now go to Excel and let's put this in. I've written it down. But I said our degrees of freedom are the two sample sizes added together minus 2. All right, so our sample sizes are 18 and 10. So that's 28. Subtract 2, we're going to use the degrees of freedom as 26. Okay, now let me go ahead and open up Excel. Okay, so here we go. Equal t.dist. Let's put in negative 2.30737. Degrees of freedom were 26 and true. And there's our resulting value. That's our p-value, 0.014626. Actually, I guess this one didn't ask for the p-value, so we can just use the negative 2.307. Let me go back. I did find the p-value if we needed it, but our critical value, our test statistic was negative 2.30737. Since it asked for the critical value, though, we need to get that from our t inverse for 0.01. So let me go back here. Ooh, there it is. All right. So equal t dot imv. 0.01 was it? Degrees of freedom are 26. And negative 2.47863. So let's notice that this is our critical value, negative 2.4. And our test statistic was negative 2.30737, which is not to the left of this, it's to the right of it. So that means that it needs to be to the left of it, like negative 2.5, to be in the rejection region. So we are not going to reject the null hypothesis. Despite that really small p-value, it wasn't smaller than 0.01. And that's a very small value of alpha there. So in this particular case, it's not in the critical region, although it's really, really close, and we will fail to reject the null. So there will not be sufficient evidence to conclude that our alternate is true. So it'll be this one. Okay, so let me see if I can find one that has, maybe they're all small for this one. Oh, they're not. There's a confidence